Welcome to Section 3, Authentication and Authorization. In Section 2, we learned how HTTPS secures communication using SSL/TLS encryption. Now, we'll focus on securing access by verifying identities and controlling permissions. You'll learn the difference between authentication and authorization, authentication methods, API keys, OAuth 2.0, OAuth components, authorization flows, access and refresh tokens, JWT, and login with Google. We'll also compare OAuth, JWT, and HTTPS before exploring how these technologies are implemented in MuleSoft. By the end of this section, you'll understand how modern APIs securely authenticate users, authorize access, and protect resources in enterprise applications.
This slide introduces the security concepts that build on HTTPS from the previous section. The center shield represents protecting identities and controlling access. Authentication answers, "Who are you?" while authorization answers, "What are you allowed to do?" The flow diagram shows the process from request to authentication, authorization, and secure access. The left panel highlights what you'll learn, why these concepts matter, and how they build on HTTPS. By the end of this section, you'll understand OAuth 2.0, JWT, API keys, and how MuleSoft secures modern APIs and enterprise integrations.
Authentication and authorization are often confused, but they serve different purposes in security systems and APIs. Authentication answers the question, "Who are you?" It verifies a user's identity using credentials, such as usernames, passwords, fingerprints, facial recognition, or multi-factor authentication. As illustrated in the figure, a user first logs in and proves their identity before accessing a system. Authorization answers the question, "What are you allowed to access?" After authentication, the system determines the user's permissions and access rights. For example, an employee may log in successfully but only have access to employee records, while an administrator can access additional resources. Understanding this distinction is essential for API security, access control, and OAuth 2.0.
This slide introduces the 4 authentication factors used to verify identity. Authentication confirms who you are before access is granted. The center shield symbolizes secure identity verification. The 4 panels represent something you know, such as a password or PIN, something you have, such as a phone or security token, something you are, such as a fingerprint or facial recognition, and something you do, including behavioral patterns. The bottom diagram illustrates multi-factor authentication, where 2 or more factors are combined to provide stronger security and better protect APIs, applications, and enterprise systems from unauthorized access. This slide explains how session authentication maintains a user's login state after successful authentication. The diagram illustrates the complete process. First, the user logs in by providing valid credentials. The server verifies the user's identity, creates a unique session ID, and stores the session data securely on the server. The session ID is then returned to the browser and stored in a cookie. With every subsequent request, the browser automatically sends the session ID back to the server for validation. If the session is valid, the server grants access to the requested resources. Otherwise, access is denied. Session authentication provides a simple, secure, and scalable way to manage user sessions, helping protect applications from unauthorized access while delivering a seamless user experience.
Basic authentication, one of the simplest methods used to verify a user's identity. The diagram begins with the client requesting a protected resource. The server responds by requesting credentials, and the client sends a username and password encoded in base 64 within the authorization header. The server decodes and validates the credentials against its user store. If they are valid, access is granted. Otherwise, the request is denied. Although basic authentication is easy to implement and widely supported, the credentials are sent with every request, so it should always be used with HTTPS to protect sensitive information during transmission.
This slide explains how API keys authenticate an application making an API request. On the left, the definition and common use cases show that an API key is a unique identifier used by applications to access APIs and services. In the center, the diagram illustrates the workflow. The client sends a request with an API key in the header or query parameter. The server validates the key and returns either a successful JSON response or a 401 unauthorized error if the key is invalid.
The right side compares the advantages and limitations of API keys and highlights best practices, including using HTTPS, storing keys securely, rotating keys regularly, and never exposing them in client-side code. While API keys identify applications, they do not verify user identity like OAuth 2.0 or JWT.
This slide introduces OAuth 2.0, the industry-standard authorization framework used to grant secure access to APIs without sharing user passwords. The hand-drawn diagram illustrates the complete authorization code flow. On the left are the key components: the resource owner, client application, authorization server, and resource server. In the center, the flow shows the user logging in, granting consent, receiving an authorization code, exchanging it for an access token, and using that token to access protected resources. The right side highlights the benefits, limitations, and best practices. Remember, OAuth 2.0 is an authorization framework, not an authentication protocol, and it works best with HTTPS to protect data in transit. Together, OAuth 2.0 and HTTPS provide a secure, trusted, and scalable foundation for modern API communication and enterprise applications. This slide walks through the OAuth 2.0 authorization code flow, the most common and secure way applications obtain permission to access a user's data. On the left are the four key components: the user, client application, authorization server, and resource server. In the center, the numbered steps show the complete process, from the user signing in and granting permission to receiving an authorization code, exchanging it for an access token, and using the token to access protected resources. The notes on the right show that authorization codes are used once, access tokens expire, refresh tokens can obtain new tokens, and HTTPS protects every step. This flow lets applications access resources securely without storing the user's password.
This slide introduces the client credentials flow, one of the OAuth 2.0 flows used when applications need to communicate directly with each other without a user signing in. Notice that the process begins with the client application sending its client ID and client secret to the authorization server. After those credentials are verified, the server issues an access token. The client then uses that token to request protected resources from the resource server, which validates the token before returning the requested data. The examples at the bottom show what a typical token request and response look like, while the panel on the right summarizes the key characteristics and common use cases. This flow is widely used for back-end services, scheduled jobs, microservices, and other automated integrations where secure server-to-server communication is required.
Access tokens, which are temporary credentials issued by an authorization server after successful authentication. The diagram on the left shows how a client requests access, receives an access token, and presents that token to a resource server instead of sending a username and password with every request. The center illustration emphasizes that the token is the key used to access protected resources. On the right are the main characteristics of access tokens, including their limited lifetime, defined permissions, secure transmission over HTTPS, and the use of refresh tokens when they expire. The bottom section highlights common use cases and best practices for securely protecting APIs and sensitive data.
In the previous slide, we learned how access tokens allow applications to access protected resources. This slide introduces refresh tokens, which help users stay signed in without logging in again after an access token expires. The diagram shows how the client sends the refresh token to the authorization server to request a new access token. Notice that refresh tokens never access APIs directly. They are only used to obtain new access tokens. The comparison table highlights the differences between access and refresh tokens, while the right side summarizes their features, security recommendations, and common use cases. Together, access and refresh tokens provide both a secure and seamless user experience.
This slide introduces JWT, or JSON Web Token, a secure way to share information between systems after a user has been authenticated. Unlike session authentication, JWT stores the user's identity and permissions inside the token itself, allowing servers to verify requests without keeping session data. The center diagram shows how a user logs in, receives a signed JWT from the authorization server, and includes that token with each API request. The sections around the diagram explain the three parts of a JWT: header,
payload, and signature, along with its key features, common use cases, and security best practices. Together, these concepts show why JWT is widely used for modern REST APIs, cloud applications, and microservices.
On this slide, we're taking a closer look at what a JWT actually contains. Every JSON Web Token has three parts separated by dots: the header, the payload, and the signature. Think of the header as describing the token, the payload as carrying information about the user, and the signature as proving that the token hasn't been changed. As you can see in the flow diagram, once a user logs in, the server issues a JWT, and the client includes it with future API requests. Before returning any protected data, the server verifies the token's signature. One important thing to remember is that a JWT is signed, not encrypted, so the payload should never contain passwords or other sensitive information. One of the most common authentication methods you'll see today is login with Google. Instead of creating another username and password, users can securely sign in using their existing Google account. As shown in the diagram, the application redirects the user to Google, where they authenticate and grant permission. Google then returns an authorization code, which the backend exchanges for secure tokens. After validating those tokens, the application signs the user in. This approach improves security, simplifies the login experience, and allows users to share only the information they choose while keeping their Google password private. At this point, you might be wondering whether OAuth and JWT are the same thing. Although they are often used together, they serve different purposes. As this slide shows, OAuth is an authorization framework that determines what a client is allowed to access on behalf of a user. JWT, on the other hand, is simply a token format used to securely carry information, such as user identity and permissions. The comparison highlights their roles, common use cases, and key differences. The takeaway is that OAuth manages access, while JWT carries verified information, making them complementary technologies in modern API security. Now that we've covered authentication concepts like OAuth, JWT, and API keys, let's see how they are applied in MuleSoft. This slide highlights the main security features available on the Anypoint platform. On the left, HTTP listener security protects incoming requests using HTTPS. API Manager applies policies such as rate limiting and token validation. OAuth 2.0 securely authenticates users and applications, while Client ID Enforcement verifies trusted clients. JWT validation confirms that tokens are authentic before access is granted. Together, these features help MuleSoft secure APIs, protect sensitive data, and ensure that only authorized users and applications can access enterprise services. Before moving on to the next section, let's take a moment to connect everything we've learned. We started by understanding the difference between authentication and authorization, then explored authentication methods, API keys, OAuth 2.0, and its main components and flows. We also learned how access tokens, refresh tokens, and JWTs work together to provide secure API communication. The flow diagram at the bottom ties these concepts together, showing how a user authenticates, receives permission, obtains a token, and securely accesses protected APIs. These are the same authentication principles used in MuleSoft and many enterprise applications, making them essential skills for designing secure, modern API integrations. We've reached the end of Section 3, and these interview questions are designed to help you review the most important authentication and authorization concepts. As you look through the questions, don't focus on memorizing definitions. Instead, make sure you understand why each technology exists, when it should be used, and how the different concepts connect. Notice that the questions progress from authentication and authorization to OAuth 2.0, tokens, JWT, and real-world scenarios. If you can confidently explain these topics in your own words, you'll be well prepared for MuleSoft, API development, and integration engineering interviews. Before we move on to Section 4, let's use this quiz to check how well you understood the key ideas from Section 3. These questions review the full authentication journey, starting with authentication and authorization, then moving into OAuth 2.0, OAuth components, access tokens, refresh tokens, JWT, and how these technologies apply in MuleSoft. The goal is not just to memorize definitions, but to think through each question and explain your reasoning. If you can answer these confidently, you'll have a strong foundation for API security, MuleSoft development, certification exams, and technical interviews.